Hi everyone, my name's Rob from RobOps, and today we're covering AWS Transit Gateway, what it is, when to use it, and I'll build a simple hub and spoke demo so you can see the routing end to end. Transit Gateway is AWS's central hub. Instead of creating lots of point-to-point connections between VPCs, you attach each VPC to a Transit Gateway once. Each of these connections is a Transit Gateway attachment. Then, the Transit Gateway uses route tables to decide which VPCs can talk to which other VPCs. The key benefit is scale. As you add more VPCs, you just need to add more attachments. You don't need to create a whole new web of connections. If you watched my last video on VPC peering, you can think of peering as a direct, one-to-one link between two VPCs. That's great when you only have a couple of VPCs, but as soon as you start to have more, you start building a mesh of connections and things get hard to manage. Transit Gateway flips that model. Instead of connecting VPCs to each other, you connect each VPC once to a central hub, the Transit Gateway, using Transit Gateway attachments. Then, the Transit Gateway handles routing between them, and you control what's allowed with route tables. And that's the core idea. Hub and spoke connectivity that scales cleanly, which sets us up perfectly for the common use cases people build with Transit Gateways. Transit Gateways have a variety of applications. Here are some use cases where the technology really shines. Transit Gateways replace the peering mesh. When you go beyond a few VPCs, especially across accounts, Transit Gateways keep connectivity predictable. One attachment per VPC, not a spider web. Shared services VPCs. This is a common pattern. One VPC hosts shared things like AD, DNS, CI tooling, monitoring, and Transit Gateway lets multiple application VPCs reach it without creating the full mesh of connectivity. Finally, hybrid connectivity when we're thinking about on-prem to multiple VPCs. If you're connecting to on-premise, Transit Gateway becomes the hub, so one VPN or direct connect can reach multiple VPCs, again, without one-off routing everywhere. Now, those are patterns where Transit Gateway shows up in real architectures, but Transit Gateway can still feel abstract until you see the traffic actually flowing. So, let's do a quick hands-on experiment. I'm going to spin up 4 VPCs and drop an EC2 instance into each one of them. Prove that they can't talk to each other, and then we'll add a Transit Gateway and Transit Gateway attachments and watch the connectivity light up. As always, the code for these experiments will all be available on my GitHub, linked below in Terraform, so you can quickly spin up these exact experiments and try them yourself. And if we go into the code view here, we have our AWS Networking Resources demo repo open. And you'll notice we have a new section here called the Transit Gateway demo. And so, like I mentioned before, we have a few modules. We have an EC2 module, Transit Gateway module, VPC, and VPC peering. In this demo, we're going to be using the VPC and EC2 modules to set up our experiment, and eventually we're going to use the Transit Gateway module to spin up our Transit Gateway. But first, we'll set it up manually in the console so you can see exactly what's involved. So if I go into the Transit Gateway demo, I'm going to see my main.tf, and I'll see that I'm essentially going to be doing a few things, defining my CIDR blocks, so 10.10, 10.20, 10.30, 10.40, just for simplicity. And I'm going to spin up 4 VPCs, A through D, using the VPC module. As you can see here, we're just going to have a public and private subnet for each in a single AZ. And we're also going to spin up 4 T3 micros using our EC2 module. And these T3 micros are going to be running a simple endpoint on port 8080 that is essentially just a hello world endpoint that we're going to try to curl to verify connectivity. And the endpoint message is going to be hello from VPC, whichever VPC we're in. So that's the first step. And if you scroll all the way to the bottom, if you've cloned this repo, you'll notice that there is a module for the Transit Gateway. This is going to be commented out because in the first iteration of our experiment, we're going to set up this Transit Gateway manually. So if I scroll up to the top and I go into my repository and I run a Terraform init, I should initialize my backend. And then I'm simply going to run a Terraform apply. And so this is going to create 4 VPCs, all of the required subnets, internet gateways, NAT gateways, etc., and 4 EC2 instances. So I'm going to click yes, and this is going to create. So our Terraform apply has been successfully completed, and we have new VPCs and new instances running in them. And so I'm going to take a quick check to look in our console, and we are going to see the new resources that we've spun up. So here I am over in the VPC center, and I refresh and I see I have VPCs A through D. And if I click on one of them, I can see the resource maps, and we have basically the connectivity that we expect. So a demo public through the route table, from private out the NAT gateway. And sorry, the public out the internet gateway. And so now if I go to EC2 and I go to running instances, I will see I have apps A through D running with almost all of the checks passed. So that's great. So now what we're going to do is we're going to just go into VPC A, and we're going to click the instance ID, and then we're going to click connect. And so here we're going to connect, and this is going to bootstrap our SSH connection. Here we are. If I go curl the local IP address, so 1.7.1.0.0's on port 8080, I should be able to connect to the script that's actually just running on this EC2 instance itself. And so if I do that, it says hello from VPC A, which is where we are because this is instance A, in 10.10, which is the CIDR range of the instance. And here's the private IP of our instance, which is great. That's what we want. Now, what will happen if I try to curl the same endpoint from the private IP of instance B? If you're thinking it's not going to work, that's good intuition, because it won't. And simply because we just have standalone VPCs right now, nothing is connecting them. But for posterity, I'm going to go curl HTTP. This is the private IP of instance B. You can see it's in the 10.20 space in VPC B. And I'm just going to curl on 8080 and see what happens. So as you can see, nothing's going to happen. Nothing's going to happen. This curl is going to hang because there is no way for this request to make it out of VPC A and into VPC B to find the instance. But that's going to change when we add the transit gateway. So now we're actually going to go and set up a transit gateway. So to do that, I'm going to go just back to our console, and I'm going to go to our VPC section. And here I'm going to scroll all the way down on the left side to transit gateways, and I'm going to click create transit gateway. So here I'm going to say my transit gateway 1, no description. I'm going to uncheck default route table association and propagation because this is a step we're going to do manually because I think it's good for the concept to land. And if I scroll down here, we're not going to assign it any sort of CIDR blocks. We're just going to simply create it. So this is going to create our transit gateway. After this, we're going to have to create our transit gateway route table, and then we're going to create 4 transit gateway attachments, 1 for each of our VPCs. All right, so now our transit gateway is up and available. So we're going to go down to transit gateway route tables. And here we're going to say create transit gateway route table, and I'm going to say my transit gateway route table 1. And I'm going to select the transit gateway that we just created and click create transit gateway route table. Similar to the transit gateway, we'll wait for this to come up. Okay, so now that our transit gateway route table is up, we're going to go over and create 4 transit gateway attachments. So to do that, we're just going to go over to the transit gateway attachments, and we're going to click create transit gateway attachment. And so here I'm going to say transit gateway attachment VPC A. And I'm going to select my transit gateway, and I'm going to select the attachment type as VPC. And then if I scroll down, I'm going to select VPC A. And I'm going to make sure that I'm in the public subnet because that is where my instances are deployed to. And then I'm simply going to create transit gateway attachment. Now I'm going to do the same thing for the next 3 VPCs and make sure that we have transit gateway attachments for each. So now we have the transit gateway attachments set up and they're in a pending state. So once these are up, we'll be able to attach them to our router. All right, so now all of our attachments are available. And if we go back to our transit gateway route table, we'll click our route table and we'll click associations, and we're going to create associations. And here we're going to attach all of our attachments to the route table. So if I click create association, I'm going to go A through D. And now I have all of my route tables associated. And you'll see they're in an associating state, but we're not done yet. We also have to propagate them. So if you go to propagations, you'll see create propagation, and we're going to propagate each of our route tables. And so if I go propagations, I'm going to go A through D again. And there we have all of our Transit Gateway attachments propagated, and we have all of our route tables associated. Now, a quick mental model, you can think of associations as which map do I read when I arrive from this attachment? And so essentially, this is a map for requests coming into the Transit Gateway to let them know where to go next. Propagations are which destinations get drawn onto this map. And so where am I going once I get to the Transit Gateway? And so that's the reason we have associations and propagations. The absence of either will interrupt connectivity. So now that we've set all this up, we are now going to need to set up our route tables. And so we're not out of the woods yet. Transit Gateway doesn't handle this for us automatically. And so if we go back to VPC and we're going to go to route tables, all the way at the top, we're going to see we have route tables for VPC A through VPC D. And so I'm simply just going to go into each route table. So VPC A route table, click edit routes, and I'm going to add routes for 10.20.0.0/16. which is the CIDR range for our VPC. And I'm going to click Transit Gateway, select our attachment, and I'm simply going to do this for the other VPCs as well. And with that, we've created routes for each of our VPCs. Now, as you can see, we've allowed everything to connect with everything, and we've created this mesh ourselves, which was actually quite involved. There's a lot of routes we had to create, and this does create some complexity when it comes to transit gateways, but it also gives you a lot of flexibility. We are able to define what should talk to when, and who should be able to talk to what. So now we should be able to test out our transit gateway. And so to do that, I'm just going to navigate back to our instances. And what I'm going to do is spin up 4 SSH windows through the EC2 Connect console. And we're going to try to ping each of these EC2 instances across our transit gateway. So now we have each of our instances with an SSH session running. And now what we're going to do is we're going to simply go into VPC A, or instance A in VPC A. We're going to curl the endpoint locally. So if I just curl the local IP on port 8080, we see hello from VPC A, where we are, instance IP 10.1.176, which aligns with the private IP here below, which is what we expect. And what we saw last time we tried this with no connectivity. So here what we're going to do is curl HTTP 10.20.1.186 on port 8080. And here we see we get hello from VPC B, IP address 10.20.1.186, which is our private instance running in B. And what we'll notice is we can curl each of these instances from VPC A. So here what I'm going to do is curl instance C, so 10.30.1.139 on port 8080. Hello from VPC C. And finally, what I'm going to do is curl, finally, just for posterity, VPC D, so 10.40.1.123 on 8080. And there you have it. It's working. And if I go here into my instance D and I say curl HTTP 10.10.1.176 on 8080, we can see hello from VPC A. So we've fully established this mesh that allows all of these instances to talk to each other through our transit gateway. And now, if I go back to our instance view and I go into VPCs and I go into transit gateways and I remove an association. So if I click this attachment here, we'll see transit gateway attachment A is ending in 5936. And so if I go to my route tables and I go to my associations and I find 5936 and I delete the association, and we'll give it a minute to dissociate, we're going to see the implications that that has on our mesh. So now that our association is gone, if we switch back to our terminals, and what we're going to try here is effectively, what impact did this have on our connectivity? And now if I try to run some previous commands like curling A, I'll notice that I hang. And I'm hanging because VPCD doesn't know where to route this request. If I go into A and try to curl D, we'll notice that I'm also not able to reach it. And so across all of our endpoints, VPC-A is currently unreachable. So if I go to 10.10.1.176 on port 8080, again, we're gonna hang. And so this shows the use of associations and propagations, and it's also a control that we can use to help shape what our traffic should and shouldn't look like using transit gateways. So switching back to the limitation, a limitation of transit gateway is definitely cost. Transit gateway is metered, so patterns like centralized egress or inspection can rack up processing charges as your traffic grows. Similarly, we can think about blast radius. Since routing is centralized, like we saw with the transit gateway router, a route table change can affect a lot of VPCs at once, as we saw when we removed the association of VPC-A. Finally, it's segmentation discipline. Transit gateway makes it really easy to connect everything, so you need to be very deliberate with route tables and which attachments you associate or propagate. So this introduces a different kind of complexity than what we saw with peering, where it was the sheer scale of peering connections that created complexity. Here, it's the details of both our route tables and our associations that can cause confusion and complexity. As I mentioned in my last video, AWS offers a variety of networking solutions for different use cases. If you're able to look at my previous video on VPC peering, we walked through the advantages, use cases, and limitations. Today, we covered Transit Gateway. But there's also other solutions like AWS Cloud WAN, which is good for establishing global networks within your environment, and VPC Lattice, which gives you finer grained controls over your application level routing. And always, thanks for watching. If you learned something new today, please consider liking and subscribing. It really helps me out. And I hope you enjoyed this content. If you are interested in future content on AWS networking tools, please comment below which one you'd like to see next. And with that said, I hope you all have a great week.